Hello everyone, thanks for taking the time to watch this Robotmaster demo. My name is John Huster. I'm with a company called Sophos Robotics, and we are a Robotmaster distributor. And today I'm going to go through the contours module in Robotmaster, and this is good for applications like cutting or trimming or deburring. I'm going to go ahead and walk through how the module is used, what you can do with the tool paths, and then how to get our robot to behave the way that we want it to. So let's go ahead and dive in. For Robotmaster, there's two separate areas in the software where you can work. The first is called the task, and I've named that trimming. And this is where you import your part. I usually like to recommend a step file because that's a very common export file type across many CAD softwares. And to do that, you would just come up here to this plus icon, select import new part, and go and find that step file on your computer and load it in. We have our operations area here. This is where we're going to add our tool paths and make any changes to our tool paths that we want for the application. And again, click on the plus icon, and it gives you the different types of tool paths that Robotmaster offers. The last pane down here is a custom frames pane. I'm not going to be going over this in this demo, but this allows you to add custom frames to your workspace for various different reasons. Once you have your toolpath programmed, you jump over to the device tab, and this is where your robot setup is located. So this device tab is where we're going to be getting our robot to act the way that we want it to act. So the first thing we need to do is we need to go ahead and create a trimming operation. And to do that, I'm going to go ahead and click on the plus icon in the operations pane, and I'm going to select contouring. And when you select contouring, it opens up this contouring detail edit screen. And the first thing that I need to do is I need to tell it what type of contouring path I want to use. So I'm going to click on the plus icon. And you can see we have edge path, auto path, swarf path, curve path, and manual path. I'll quickly go through what each of these paths do, and then I'll go ahead and program the part very quickly. So edge path, if you select that, essentially what it does is any line entity that you hover over, it will give you an edge path for that. And all you need to do is left click, and that will start to put those edge paths in place. The next is auto path. This is a very nice feature where you can select the surface and it will automatically create those paths for you. And you can filter down here by smallest path to largest path. So you can see those disappearing in order, or largest path here to smallest path. From there, we can look at swarf path. This is the one that I would use for this one, and it's because a swarf path keeps the flutes of the tool up against the wall that you select. So if I select swarf path, I can zoom in and select my path, and you can see that it highlights a light blue and it automatically chains together any paths that are connected. And then I would come up and select my rail that I want to use, and it will give me that tool path. If I zoom out, you can see it's giving me a tool path around the entire part. You have curve path. I don't have a good way to show this here, but I can explain it to you. A curve path is going to be any kind of wireframe or line entity that you have on the face of your part. You can use a curve path for, and it allows you to select that wireframe and use that wireframe as a tool path. Manual path is the last one, and it's exactly what it sounds like. You can create a custom path on your part to fit your needs. And you can see I can just keep drawing on this part however I want to. And there's a couple different settings you can go through that I'm not going to go over in this video, but it allows you to manually draw tool paths on your part. So back to programming the part, I'm going to use a swarf path because I want the flutes of my tool to stay parallel to this wall. So I'm going to go ahead and add a swarf path here. I will select this edge, I'll select the upper rail, and that selecting that upper rail gives me the orientation that I want my tool to be in. If I were to select the lower rail, it would essentially flip all of these vectors 180 and we would be upside down. Let's go ahead and do that. I'll do it for these others as well. So this guy here, this guy here. And you can see with just a couple clicks, I've got all of these points programmed and ready to go. The next thing I could do is I want to make sure that I'm going in the correct direction for my tool offset. So for instance, on this path, I'd want to be to the right, which is correct. This path is also to the right. And this path looks like it might be going in the opposite direction. So I'm going to select it, come over here and right click and hit path, invert direction. Perfect. Go ahead and click OK, and now we have our 3 paths here that we can start manipulating. So one thing you can do that's helpful is I can change where I want the start point. That is indicated by this red pin. I can left click and I can drag this to wherever I want it to be. I can also click this little chain link here if I don't want to do the entire path, and this will allow me to select the section of path that I'd want to do. So if I just wanted to do this much, I could right click, or I could left click, and you can see it would just do this much of the path, with the green pin being where it's going to start and the red pin being where it's going to end. I just kind of went over how to reverse the direction, so if you wanted to reverse the direction, you could. I'm going to undo that. So let's make sure all of our paths are correct. So I'm just going to change this guy to kind of be in the middle of this feature here, and I'll change this start position. I'm just kind of pre-ordering in my head here. Do something like this. So we'll start with this path. So I can move that up to the top to order it the way that I want to. Next I want to do this path. So I can order it there. So on and so forth. So now we've got our start points, we've got our order. The next thing we want to do is we want to make sure that our tooling is correct. We have a 10mm flat end mill, that looks good. At any point you can hit apply here and it'll keep you in this window, but it will show you a preview of your toolpath. So I can see we're going around, that looks good, that looks good, and this looks good as well. So the next thing I want to do is, if I zoom in on this toolpath, you can see that my tool is splitting the middle here. So I want to come in here and I want to offset this to the right. Click apply. And I can tell that these are offset to the right now because this little blue path was essentially right on the bottom of this edge, but now it's bumped in, and so everything is offset correctly. So that looks good. If I wanted to change the depth of cut, if I wanted to cut deeper, that would be in this retract heights. I think everything's pretty good here. We could do arc filtering if we wanted to. That would help with, might help with some. I think we're okay though. This will essentially, instead of outputting a bunch of linear moves to get around an arc, it'll fit an arc to that curve and output circular moves. So we're going to go on to the retracts option here, and this gives you several different options for how far you want to clear after you're finished programming that, or after you're finished running that toolpath. So you've got clearance, approach, retract, feed, and depth, and you can see it gives you a couple different options for what method you want to use. I'm not going to cover that in this video. It also gives you a couple different references and a distance. How far off do you want this to come for this move, and then a motion type, joint, or linear. It's essentially the same options for clearance and approach, retract, and then feed is essentially your height right before you engage your part. But for instance, if we wanted to adjust the depth of this toolpath, I could come in here and I could say, you know, for dramatic effects so you guys can see, I'll do negative 25 millimeters, and we should see this whole toolpath drop down 25 millimeters. Like so. So this could help you to adjust for where you want to hit on that flute. Go ahead and put that back to 0. The next option we have here is our entry and exit. And what this allows us to do is define how we want the robot to start engaging these parts in this toolpath. So if I toggle this switch on, it defaults to a perpendicular line. I'll bump it out a little bit so that we can see it. I'm just going to briefly go over this, but there's a couple different options. So for my entry, I want a line length of 25 millimeters. Same for my exit. If I hit apply, you can see that at each toolpath, it gives me that entry and exit there. So now instead of coming right down into the part, we would come down into a section of the part where it's going to be trimmed off, and then we would start our toolpath. And there's a couple different options for that. There's perpendicular line, tangent line, arc, line arc. So if we did line arc, this gives us a line distance, an arc radius, and a sweep angle. And you can see it results in the toolpath you see there. So this gives us some good options for how we want to lead into the part. I'm just going to leave that off for now, but it might be a good option for your application. So this all looks pretty good. What I'm going to do though is I don't want all of these in one operation. I want to split these toolpaths up into separate operations so that I have a little bit more leniency in how the robot acts and transitions in between each one of these. So I can hold shift and highlight both of these guys, right click, extract path. Oh, one other thing I wanted to show you before we do that is, for instance, here, if you have a thermoform part or a plastic part that you get some warpage in, or you need to edit some section of it, you can come in here and I can left click, hold shift to highlight a certain section, and then I can actually right click there, go to path, and split that path. So now you can see it split it into that section plus the remainder. And then I can come in here and I can right click, transform path. I can move it, I can scale it, I can offset it, I can mirror it around an axis. But if I wanted to move it, then you can see I can select move, and then I can move this section of this path however I want to. So that was just kind of a quick little adder there. So I'm going to undo that. Now I'm going to go ahead and split my paths. So I'll left click, hold shift, left click, right click, extract paths to one operation per selected item. Click OK. Let's go ahead and go back to a good view. And now you can see I've got contour 1, or 2 I guess, 3, 4, and if I want to reorder these, I can just left click and hold on these 3 lines, reorder their operation, and we should be good. After that, what I like to do is rename them to whatever I'm going to call the subroutine, because it'll essentially post this as the job name. So for this, I'm just going to real quick just name them 1, 2, 3. You can name them whatever you like. You essentially just double click, type in what you want, hit enter, and you should be good. Now that we have our paths the way that we want it, I'm going to go ahead and go to the device side. I'll hit calculate, and what you'll notice is over here on the left in the operations, we have our home position, operation 2, 3, and 1, and again I want operation 1 to be first. Okay, so that looks pretty good. So for this operation 1, I can start simulating through just to see what kind of errors I'm getting. These green dots here, I guess these are green, but these dots will indicate if there's any issues with the toolpath for kinematics, so out of reach, joint limits, wrist flips, singularities, things like that. And if you see this lightning bolt, that is indicating that there is a collision, and it'll let us know that there's a collision because there's a lightning bolt here, but also if we click on it, it will show us by highlighting what is colliding in our simulation. So this looks good, this operation 1, so I'll just kind of peruse through that really quick. We can see we're going to go to this operation 2, and we're getting that collision here. What's nice is you can dynamically check for a solution here. So if I left click, I can then rotate my tool, and I can see that there is clearance there if I just rotate my tool a certain amount. I'm going to have to get that out so we can see a little bit more. So I can go into the settings of this operation, and this is in the axis configuration page. What I can do is there's a tool orientation option here, and it's got a bullseye. And if I click on this bullseye, it's going to scan this whole operation and see if there's a tool orientation that works for everything. And once it's scanned it, it's going to give us this ring. And once we have this ring, any green section is indicating, hey, if your tool's at this orientation, then it will complete the tool path without any kinematic errors or collisions. So I'll just go ahead and click apply. And if I go back and click OK, you can see that it's gotten rid of the issue of that collision with that tool path. So we can watch this tool path and everything looks pretty good there. And finally, on to the last operation. This is going to be the outermost cut of the part, and we can see right out of the gate that we have, not only do we have a collision, but we also have an out of reach, and the way we know that is this tool has disconnected from the robot. So we have an out of reach, we have a collision. Again, what we can do is we can try to come in here with axis configuration. We'll type in -90, click OK, and that'll rotate the tool -90 degrees, which gets our collision out of the way. But you can see we still have a red dot here indicating an out of reach. And what that axis configuration has done is it's put a -90 degree rotation on the entire tool path around the z-axis of the tool frame. So because we did that, as we get farther out, you can see that the robot disconnects from the tool, indicating an out of reach, but we know we can reach this because we can dynamically toggle this tool and see that, hey, the robot reconnects, so clearly we can reach this area. So Robotmaster's come up with a really clever solution to this where you can actually spin the tool around the z-axis at every single point. So if you think of what we just did in the axis configuration, we put a -90 degree rotation on every point, but really what we need is a -90 degree rotation here, but as we get out, we need to open that wrist up so that we can reach the far edge of that part. And so we need to put a different Z rotation out here at the tip of the part than we have at the beginning. And they do this in a really clever way. They actually plot it visually. So I'm just going to go into the settings. I'm going to select optimization right here. And you'll see this blank canvas here, and essentially what you have is degrees of rotation around the Z and then points for the toolpath. And I'm going to click generate map. And over here on the left you can see our legend here, and it's showing you what the colors in this map represent, right? So we have singularities, out of reaches, joint limits, over travels, wrist flips, and collisions. These are every type of possible kinematic or collision area you can have with a robot. And we're seeing here exactly what we saw in that simulation, which is about halfway through that tool path. Our tool disconnects and it's this blue blob, and that is indicating that it's out of reach. Now what's really great about this is we can manipulate this line around these blobs, and then it will put the correct tool, the correct rotation around the z-axis of our TCP frame. So I'm going to go ahead and I'm going to add a point there. I'm going to add a point here. I'm going to add a point here. And I call them anchor points, and that's just essentially so nothing to the left of this moves. And then this is another anchor point, nothing to the right of this moves. But then I can left click and hold this middle point and drag it down out of the way. And as long as we're in the clear, in the white space, we shouldn't have any more kinematic errors. And so if I go ahead and click OK, you can see here we've gone from having a red dot to a green dot. indicating that all of our kinematic issues are solved. And if I simulate through, you can see we're starting at that -90. And as we continue down that path, we'll see that wrist open up. And as we get close to the robot to avoid collisions, you'll see it'll curl back in on itself. Perfect. So, in conclusion, the contouring module is great for any kind of trimming or deburring application. You can see when we went through and programmed the tool paths, it was a couple of clicks. We get our parameters set. The other nice thing is I can actually set all of my settings as a preset, so I can hit export settings to preset, and what that does is it saves all of the settings we went through and set here, so that later, if I'm doing more paths that are going to be the same parameters, I can just go in, click the path that I want, click OK, come out here, right click, and then there will be an import preset. And then we just import that preset, and it automatically sets all of the parameters for that toolpath. And we also have that on the device side as well. You can create what's called a recipe. So export recipe here, name that recipe whatever makes sense to you, and then for subsequent toolpaths, you can import that recipe. So once you get your library set up, it really becomes a matter of clicking where you want your toolpaths, importing your presets, importing your recipes, and you're ready to post the job. So hope you guys enjoyed this. If you have any questions, feel free to reach out. Thank you.